everyone, welcome to Rocket Raftar. So today we are studying 12th Science Physics, Electric Charges and Fields. First of all, let me tell you that this chapter is super awesome, and we're starting with physics because physics is, super awesome. That's why everyone says that physics is hard and physics is bad, but physics is actually super awesome when you start understanding it, right? So let's start the chapter. Okay, so first of all, these are the topics that we are going to study today: electric charge, how to charge any object, electroscope, charge quantization and conservation, and electrostatic force or Coulomb's law in scalar form. These are the topics we are going to study today. So back to the first topic. Now, when we start a chapter, we must know what the title of the chapter means, what the chapter's name means actually. Now here the title is electric charges and fields. So as a science student, we must know what is an electric charge, right? And even if you don't know, let me tell you that we know that most fundamental thing in this universe is an atom. Biologically, it's a cell, but it's an atom, okay? And the atom consists of electrons, protons, and neutrons, where protons and neutrons reside in the nucleus and electrons revolve around the nucleus, right? This is an atom where neutrons are considered as neutral charges, protons are considered as positive charges, and electrons are considered as negative charges. Okay, so we now know the meaning of this chapter, and electric field is what we're going to learn forward. So let's start with the first topic, which is electric charge. Okay, so as I told you, there are two types of charges: positive charge and negative charge. Okay, we'll write it, there are two types of charges, which is positive and negative. Okay, well, I want to tell you that first, this charge is the internal property of any object. Like mass is an internal property of any object, charge is the internal property of any object. Okay, charge is what? It's internal property of any object. Now, if it's any property, right? If it's any kind of physical property or something, you must have a question that there must be an SI unit or something that we could define it as, right? There is an SI unit for charge. Well, what is that SI unit? SI unit for charge is what? It's capital C. It's Coulomb. It's called Coulomb. And the dimensional formula for Coulomb is A1 and T1. It comes from the Q equals to IT formula, which is something that you have learned already in the 10th class. Okay? And now, the charge carriers. What are the charge carriers? What are the carriers that, what are the particles that carries these positive and negative charges? Well, this is something that is most fun. It's proton and electron. Proton carries the positive charge and electron carries the negative charge. Well, we'll write that too. Proton are the positive charges, positive charge carriers, while electrons are negative charge carriers. right? Now this positive charge carriers and negative charge carriers. One second. Okay. Now protons and electrons. Now the amount of charge a proton carries is plus 1.6 into 10 raised to minus 19 Coulomb. This is the amount of charge a proton carries, and this is a data you must remember, okay? And an electron, this is the fundamental data, so you must remember this. Electron carries minus 1.6 into 10 raised to minus 19 Coulomb. And one more data is there, what is the mass and mass of proton and electron. So mass of proton and mass of electron is also the fundamental data for studying physics and chemistry and science. So mass of proton is minus 1.6, no, there is no minus, sorry, 1.67 into 10 raised to minus 27 kg. And the mass of electron is 9.1 into 10 raised to minus 31 kg, right? Okay. Now, if the proton is a positive charge carrier and the electron is a negative charge carrier, there must be some kind of forces between them, right? Some kind of forces. Now, proton and proton, if either it's proton or electron, there will be what kind of force? There will be repulsive force between them. Sorry, my mistake. There will be repulsive force between them. And if it's proton electron, there will be attractive force between them. Right, between them. So this is almost all kind of data that is necessary for knowing what is an electric charge, that there are two types of charges, positive and negative, and that the charge is an internal property of any object. The SI unit is Coulomb, and the dimensional formula for Coulomb is A1T1, which came for the formula Q equals to IT, okay? And the proton carries the positive charge, electron carries the negative charge. Proton has 1.6 into 10 raised to minus 19 Coulomb, electron is minus 1.6 into 10 raised to minus 19 Coulomb. The mass of proton is 1.6 into 10 raised to minus 27 kg, 9.1 into 10 raised to minus 31 kg. There is repulsive force if there are like charges, and attractive force if unlike charges. The same as we see in magnets, like north and south. So it's basically the same, everything it is, okay? Now for the next topic, we have how to charge any object. Okay, so we know that everything on this planet, everything on this earth is neutral. That is something I forgot to write here. Let me write it, okay? Every object is by default neutral. What it is? It's neutral. Means positive charge equals to negative charge. There are positive charges and negative charges, same amount in any body, right? So any object is neutral by default. By charge, by default it is neutral. So if you want to charge any body, how can we do it, right? So how to charge any object? Well, there are basically two ways to charge any object. The first one is by rubbing, and the second one is by induction. The first method is something what you see in your everyday life. Rubbing is is something that you see in your everyday life. For example, let me show you something. these are some pieces of paper in my hand. As you can see, these are some pieces of paper in my hand, and this is the pen, and I will rub it with my hair. As you can see, the paper is stuck with the pen. Why? Because when I rub the pen with my hair, the pen is charged. It's negatively charged. Why? I'll show you. I'll teach you actually. It's really interesting how rubbing can do magic. Okay? So, what are we starting with? It's rubbing. Okay, so first what I did, I rubbed the pen with my hair, and what happened in the end, what happened as the result, the pen was charged, because when you rub any solid object with any furry object or any hairy object, with any furry or hairy object, as a result the solid object is negatively charged. Because why? Because solid and hairy or furry object, when these both are rubbed, what happens? The hair or the fur that is rubbed with, they have less electronegativity. One second. Hairy it has less electronegativity, and because of that the atoms are lost. Electrons are lost. The electrons are lost, and the electrons are gained by loses electron, and this gains electron because it is rubbed with it, so it gains the electron, right? Like this. Let me show you. This is a plastic rod. This is hairs. So it basically loses electron and it gains electron like this, and it becomes negatively charged, and this becomes positively charged. It's as simple as that, right? So this is how with rubbing we can charge any object. And now let me show you the mathematical formulation of this. Suppose this is for before. One second. Yeah. Before. This is solid object and this is hair before rubbing. This is the condition before rubbing. There are positive charges and negative charges, but both of them are equal in number, okay? And in here too, They are equal in number. Now what happens after? What happens after? The hair loses and the object gains. For suppose the hair loses 2 electron, right? So the composition will be like this. 1 2 3 4 5 1 2 3 4 5 1 2 3 4 5 and 1 2. So there are gain of 2 electrons, so it will be minus 2 electron, and 1 2 3 4 5 and 1 2 3. There is the loss of 2 electrons, so it will be plus 2 electron, right? So here it's positively charged and it is negatively charged, right? So this is the composition, this is how actual thing works, and actually there is a formula for this. Actually it's not a formula, but you can make it as, right? So capital Q equals to NPE minus NEE. Now what is NP and NE here? You must will ask, where NP is the number of proton and NE is the number of electrons, and E is the fundamental charge, which is, I told you, 1.6 into 10 raised to minus 19 Coulomb, and this you have to remember it, where Q is the charge. Charge is always denoted as capital Q or small q. Charge is denoted as what? Charge is denoted as capital Q or small q. Okay. So I told you about the rubbing condition. So this is formula. If we take E common, then the formula will be like this. And yes, this is really important because it gets asked in most of the competitive exam. Okay. Now next, with induction, I told you how we can charge an object, how we can charge an object with rubbing. Now the second method is induction. How can we charge an object with induction? Now induction also has two processes. Its first one is without touch, and the second one is with touch. And the with touch process also has two. I'll tell you later, okay? Now, first we'll go with without touch. First we will learn how induction works. Now what is induction first? It's like magic. It wasn't before and it now is. Means pehle wo nahi tha aur ab wo hai. It's induction. It's magic, okay? So let's start with first. It's without touch or without any conducting wire. Okay, so first let's take two metal spheres like this. We took two these are what? This is a metal sphere. Okay. Sorry, only one metal sphere is needed, huh? Okay. So first let's take one metal sphere. Now what are we going to do with this metal sphere? Now as I told you, everything is neutrally charged, so there are positive charges and negative charges in this metal sphere which are already neutralized. So we are going to first bring a negatively charged rod near the metal sphere. Now what will happen if we do this? Just think about it. What will happen if we bring the negatively charged rod which has negative charges? What will actually happen? if we think logically, what will happen? The positive charges will come along to the side where the rod is, and the negative charges will transfer to the another side. Okay, this will be the scenario when we bring the negatively charged rod near to the metal sphere. Okay, now what we are going to do is, this is the metal sphere and we are going to do earthing. Now what are we going to do? Earthing. And what earthing does is, earthing always neutralizes. That means the negative charges that are residing here will all be earthed, means they will all disappear, okay, or they will be neutralized by earth. So the last position, the last place, this will be the last structure or the composition this metal sphere will have is this: positive charges, positive charges, positive charges. And when we remove this rod is still here, and when we remove this negatively charged rod, the positive charges will be redistributed, distributed in the whole sphere, in the whole sphere. Okay, this is what is going to happen. And now, first there was no charge, there was it was neutralized, and now it's positively charged. Now the metal sphere is what? Metal sphere is positively charged. So there was no charge before and now there is charge. So this is what we call induction. Yes, this is what we call induction, because there was no charge before and there is now positive charges. So this is induction without touch. Okay, now moving to the next topic, it will be with touch. Now how does induction works with touch? Let me see. Now this one is pretty interesting. With touch. Now first we have to know that with touch there are two cases, two scenarios, or there are two cases. The first case is with identical spheres. Identical spheres. And the second one is unidentical spheres. Okay, this is it. Now before this I want to teach you a topic, that is additivity of charges. Before we start induction, I want to teach you this additivity of charges. Now what is additivity of charges? It's super easy and it's super logical if you think about it a little. Now for suppose this is some kind of object, okay, and there is +4 charge here, and there is +4 Coulomb charge here, there is +4 microcoulomb charge here, there is -2 microcoulomb, here it is +5 microcoulomb charge, and here it is -6 microcoulomb charge. So what will be the net charge, or what will be the total charge of this object? Now let's see total charge of this object. Now what you have to do is make an algebraic equation, which is not so hard. +4 -6 -2 and +5. So what will be the answer? -6 -2 it's -8, and 4 + 5 it's 9. So 9 - 8, 1 microcoulomb. This is your answer. So when there is total charge asked, okay, when there is an object with so many different kind of charges distributed in it, what will be the total charge? We have to find the total charge. Then this total charge will be this. You have to just add all the charges which are with their respective signs. You have to add all the charges with their respective signs. So this is additivity of charges. Okay, now moving to next, it's with identical sphere. We are starting first identical spheres. Okay, identical spheres. Now suppose there are two spheres like this. Okay, there are two spheres. This one has some q1 charge. One second. This one has some q1 charge and this one has q2 charge. Okay, this is sphere 1, this is sphere 2. It consists of some q1 charge and this consists of some q2 charge. Okay, that you understand. Now what are we going to do actually? We are going to connect it with a conducting wire. q1 dash and q2 dash. q1 charge se aana hai. There will be, here will be q2 charge. Okay, so what we did is we connected this two spheres with a conducting wire. This is what? This is a conducting wire. Now what are we actually going to do is, now we will separate this both spheres again. So the charges, because we connected it, the charges will get redistributed. Okay, so in sphere 1 the charge left will be q1 dash and the charge left will be q2 dash. Now what are this q1 dash and q2 dash? We have to find that. Okay, so when there are identical spheres, means they have equal radius. Their radius is what? Equal. R1, here R1 equals to R2, means they are identical spheres. So here the scenario will be the q1 dash equals to q2 dash will be what? Will be their average. q1 plus q2 divided by 2. Okay, this will be the formula if you want to find the charge after we remove it. For suppose there is a charge with 3q and here it's 2q. Okay, so this is a sphere 1, sphere 2. It's an example. Okay, this is an example. There is a sphere with 3q charge and there is a sphere with 2q charge. What are we going to do? We're going to connect it with conducting wire. Okay, now after we remove it like this, what will be the charge in sphere 1 and what will be the charge in sphere 2? So q1 dash equals to, we have to use this formula, q1 dash equals to q2 dash, q1 plus q2 divided by 2. Means here q1 dash equals to q2 dash equals to, here q1 is 3q and q2 is 2q. So 3q plus 2q divided by 2. So 3 plus 2, 5q divided by 2. So in this 5q divided by 2 and 5q divided by 2. This is your answer. As simple as that. Isn't it simple? Okay. Now unidentical spheres. The second case. Unidentical spheres. Now unidentical spheres means what? Both of the radiuses are not similar. They are different. So this will be R1 and this will be R2. There is Q1, there is Q2. Already charges there are. Now what are we going to do? We are going to connect it Q1, Q2 and then separate it. Q1 dash, Q2 dash. Now we have to find this Q1 dash and Q2 dash, but these are unidentical spheres. That is why we cannot use that average formula, okay, that we used earlier. So Q1 dash and Q2 dash, right? First, this question is solved in 2 steps. It's not a big of a 2-step. It's just first we have to do capital. We have to find capital Q. Now what is capital Q? Capital Q is the addition of the earlier charges. of before we touched them both, what were the charges before? The initial charges, if I say, capital Q is the sum of the initial charges of the both spheres. This will be our first step. Now, the second step will be what? The Q1 dash will be equal to capital Q into R1 by R1 plus R2, where R1 is what? R1 is the radius of sphere 1, R2 is the radius of sphere 2, Q1 dash is the final charge after we did all the experiment, final charge of the sphere 1, and Q2 dash the same as Q1 dash, capital Q, but here there will be on the numerator R2 will be there, R1 plus R2. It will be as similar as that. Okay? This and this for what? For unidentical spheres, when the spheres are unidentical or have different radius than each other. Okay, so our induction is completed. What we studied in induction? That there are we can induce charge with two types of methods. It's with touch or without touch. Without touch, we can do it by earthing and bringing the metal rod with the sphere and all that we studied, right? And with touch, there will be two cases: identical spheres and unidentical spheres. So this is basically so easy and so simple. It's very simple. So this is what we learned in induction. Now the next is, and we also learn additivity of charges. Now with touch, identical, we learned this example too, unidentical. Now quantization of charge. What is quantization of charge? Okay. What is quantization of charge? Now there is a line in NCERT that is super important, and that you have to remember it or memorize it if necessary. Newly obtained charge or newly charged IMP. Newly charged is always integral multiple of fundamental charge. Now what does this line mean? That newly charged is always integral multiple of the fundamental charge. Now actually what it means is this formula, Q equals to NE. This formula you must have seen it in somewhere in the textbook of 10th class NCERT, right? Because it was there in this chapter, and if you hadn't studied it, I cannot say anything then. Okay, so Q equals to NE, where here N is the integral. It's 1, 2, 3 and whatever, and E is the fundamental charge, which is 1.6 into 10 raised to minus 19 Coulomb. Okay, so Q equals to NE. This one is important, and this formula is important. So this is basically a very small topic, quantization of charge, but you have to remember this formula because it's going to be used in every single step of electrostatics. If you're studying electrostatics, 12th physics, the first 3 chapters are electrostatics, and then there are chapters of electromagnetics, but this formula is super important. Okay, so please do memorize this and remember this. Okay, now next, that's electrostatic force. Wow, we have come to the finale. It's not the finale of the chapter, but it's kind of, it's super good. I don't know what to say else. Okay, so let's get started. Electrostatic force. Now, we just learned before, we just wrote before that the forces between like charges are repulsive and unlike charges are attractive. Okay, now what kind of force this is? What kind of force? Electrostatic force is applied to the smallest, the fundamental objects like electron, proton, neutron. The forces between them, electrons and protons, the forces between electrons and protons are called electrostatic forces. Okay, the forces between charges, let me even write that. The forces between charges, between the two type of charges, which is positive and negative, between the two type of charges positive and negative, between the two type of charges positive and negative is called electrostatic force. It's called what? It's called electrostatic force. The electrostatic force between like charges is what? It is repulsive. And between unlike charges, it is what? It is attractive. It is super simple to remember, right? This is the fundamental knowledge of the electrostatic forces. Okay, this is fundamental knowledge about the electrostatic forces. Now if we get into the mathematical kind of equation kind of thing, okay, the Coulomb, there is a scientist called Coulomb who found the equation for electrostatic force. That is why there is called that's called Coulomb's law. Okay, so we will now write Coulomb's law, which is also very simple. Coulomb's law. Okay, what is Coulomb's law? Now let me write the definition for it. The force, the electrostatic force. What kind of force? Electrostatic force, which is between the charges. Electrostatic force is directly proportional to the directly proportional to the product of the charges, product of the two charges and inversely what? Inversely proportional to the what? To the square of distance between them. Square of distance between them. This is called Coulomb's law. This is called Coulomb's law. This is Coulomb's law. Now, isn't it simple? Now, we are going to write it in mathematical formulation. F is first, therefore, F is proportional to product of the charges. Means, let's say charge 1 is Q1 and charge 2 is Q2. So F is proportional to Q1, Q2, and F, this is equation 1. F is proportional to, inversely proportional to, the R is the distance between the two charges. So here let me write it. Q1 charge 1, Q2 is the charge 2, and R is the distance between the two charges. Distance between the two charges. Sorry, my writing is a bit messy, but I am writing this fast, so sorry, forgive me for that. Okay, so F is proportional to the product of the charges, means Q1, Q2, and F is inversely proportional to the square of the distance between them. So what do we get? F from equation 1 and 2, F is proportional to Q1, Q2 divided by R square. If we remove the proportionality signs, we must put a constant, right? F equals to K Q1 K Q1 Q2 divided by R square. This is your formula for electrostatic or Coulomb's force, where K is what? Here K is what? It's Coulomb's constant, Coulomb's proportionality constant. Okay, where K is what? Coulomb's proportionality constant. Now let's write some information about this K. Who is this K? K is Coulomb's constant first. K is, and the value of K is 9 into 10 raised to 9. 9 into 10 Newton into meter square upon Coulomb square. This is the unit, Newton into meter square upon Coulomb square for K, and this is, you must remember it. This is the data you must remember, because this is super important, that's why. Okay, so K equals 9 into 10 raised to 9 Newton into meter square per Coulomb square. This you really have to remember it. And K is 1 by 4 pi epsilon 0. Now what is this epsilon 0? What the hell is this epsilon 0? Well, epsilon 0 is the permittivity in vacuum. It is what? It is permittivity in vacuum. Now what is permittivity? What the hell is permittivity? Well, it's kind of, the allowance they give, the allowance of the force that can act in the vacuum, right? Like the medium, जो मीडियम में चार्जेस है, राइट? जो मीडियम में चार्जेस अवेलेबल है अभी के अभी, उस पे फोर्स कितना % एक्ट कर रहा है, दैट इज एप्सिलॉन 0. ओके, दैट इज एप्सिलॉन एक्चुअली. एप्सिलॉन 0 मीन्स वैक्यूम है, वो फोर्स को कितना एक्ट करने दे रहा है एक दूसरे के ऊपर, दैट्स परमिटिविटी. ओके, कितना एक्ट करे, दैट्स परमिटिविटी. एंड और वैक्यूम की परमिटिविटी फुल होती है, 100% फोर्स दोनों पे एक्ट करते हैं. दैट इज वाई K equals to 1 by 4 pi epsilon 0. Pi is that 3.14. It's your pi. So the formula for force can also be Q1 Q2 divided by 4 pi epsilon 0 R square. If we substitute K as 1 by 4 pi epsilon 0. Okay. Now this is small k actually. Now there is capital K2, which is also called dielectric constant. Dielectric constant. Now what is this dielectric constant? And yes, epsilon 0 equals to 8.854 into 10 raised to minus 12 Coulomb square upon Newton into meter square. This is the data you also have to remember it, the value of epsilon 0, because this is the numerical value, and yes, you have to remember it, 8.854 into 10 raised to minus 12, and the unit of epsilon 0 is Coulomb square upon Newton into meter square. Okay, and now dielectric constant capital K. Now what is this dielectric constant? Dielectric constant is the ratio of the permittivity in a medium to the permittivity in vacuum. Epsilon is the permittivity in medium. Let me write. Epsilon is permittivity in medium. For suppose water or whatever kind of medium there is. Permittivity in medium. And epsilon 0 is permittivity in vacuum, which I have already written here. Permittivity in vacuum. Okay, so this basically covers all kind of data for electrostatic force or the Coulomb's force. Okay, Now first of all this, and I guess we missed a topic, it's electroscope. Electroscope. What is an electroscope? Well, electroscope is basically a kind of device. It's not even a device, it's kind of a setup. Okay, it's kind of a setup or an instrument used to check if there is a charge in any object or not. Okay, it used to check if there is any charge, a device or maybe a device or setup used to check if there is any charge, if any object is charged, if any object is charged or not, object is charged. Well, this electroscope is basically like this. Well, this is okay, this is a container, or you can say it as that. This is a metal knob, this is metal rod, and one second, this is gold leaf. What it is? Gold leaf. Okay, now what we actually have to do with this setup, we have to actually this is charged, negatively charged rod, that we brought near the knob. And if we brought near the knob, you know what will happen? The charge will flow. Okay, so the charge from here will flow inside, means there will be negatively charged, negative, everywhere negative, and the negative charge will also go in the gold leaf. And what will happen to the gold leaf? The gold leaf, suppose it's like this, and this, my hand is the gold leaf, okay, and this is the metal rod. So it's like this actually. When the charge will come and flow, what will happen? Of course, there will be in this leaf too, and in this leaf too, there will be negative charge. So the leaves of the gold leaf will be diverged. That will happen. That it will diverge, and the gold leaves will diverge. What happens? It will diverge, and the degree of divergence of the gold leaf shows what? Of the gold leaf indicates that the body was charged, that there is charge in the body, in the object that was touched, in the object or in the body. Okay, so this is basically the setup of an electroscope. It is super simple. You know, when I first heard the name of electroscope, I was like, what is this electroscope? I mean, I thought it was some kind of very complex device that measures something very complex that will be never understood by me, that I can never understand. Okay, but when I actually studied this, it was actually like, what the hell is this? It's super simple, and why the hell is this like, and why the hell this name is like that, right? Okay, so it's electroscope. So what we studied: Coulomb's force, electrostatic force, electroscope, induction, additivity of charges, quantization of charges, and there is a topic actually, conservation of charges. So actually conservation of charges, it's not that hard, it's super simple. Let me tell you just a conservation of charge, what it is actually. Let me write it actually, conservation of charge, right? Conservation of charge. Now what is this conservation of charge? In an electrically isolated system, electrically isolated system, the total charge will always be 0. The total charge will always be what? 0 not, it will always be conserved. What do you mean by conserved? Conserve means कुछ किसी चीज़ को बचाना. Conserve means किसी चीज़ को extinct होने से रोकना और किसी चीज़ को बचाना, right? तो conserved है. तो टोटल चार्ज कैसे कंजर्व्ड होता है एक इलेक्ट्रिकली आइसोलेटेड सिस्टम. इट मीन्स पहले जितना चार्ज है आखिर में उतना ही चार्ज रहेगा. एंड देयर इज अ डेफिनेशन, चार्जेस कैन नीदर बी क्रिएटेड नॉर बी डिस्ट्रॉयड. चार्जेस कैन नीदर बी क्रिएटेड and nor be destroyed. Nor can be destroyed. The charged particles, the particles which carries the charge, the carrier particles can be destroyed or created in the way, but the charges can never be, okay. The neutrons can be made in nature to proton, can be divided in the nature to proton and electron, but there was one, suppose there was a neutron had one positive charge and one negative charge, it was created into an electron and a proton. So before the total charge was 0 and after the total charge is always 0. That is why the charge is conserved, and this is the meaning of conservation of charge. In an electrically isolated system, this is the line of NCERT actually. In an electrically isolated system, the total charge will always be conserved. Okay, that is you have to remember. Now next. Now there are actually, now today's topics is actually completed. So there are some important points that are not given in NCERT, but you have to remember it as for the competitive exams and all that. Some data it is. So just remember it, some data it is, okay. So SI unit of charge, we know it's Coulomb, and the dimension formula is A1 T1. So actually this is the SI unit, and the CGS unit means centimeter gram second. The centimeter gram second, or the CGS unit of charge will be, there are two. It's electrostatic. In electrostatics there is one, and there is one in electromagnetic. So in electrostatic it's state coulomb, and in electromagnetic it's AB coulomb. Okay, it's what? AB coulomb and state coulomb. And this is 1 coulomb equals to 3 into 10 raised to 9 state coulomb. In this, these both are CGS. This is in electrostatic, this is in electromagnetic. So 3 into 10 raised to 9 state coulomb equals to 1 by 10 AB coulomb. Okay. Next one is, there is up quark and down quark. It's just a name, so you just have to remember it. What is an up quark? Is 2 by 3 electron. E is 1.6 into 10 raised to minus 19 coulomb. So what is up quark? Plus 2 by 3. And down quark, you can easily remember it because up means positive, down means negative. So plus 2 by 3 and minus 1 by 3. Okay. And this is just some old stuff, but you have to remember it. UUD means a proton and UDD means an electron. Okay. Now next, dielectric constant, we studied it just now. Dielectric constant, capital K, the permittivity and all, epsilon by epsilon 0, and you also have to remember that. So dielectric constant for conductor, it's infinite. It's what? It's infinite. Dielectric constant for conductor is infinite. For air or vacuum it is 1. I just told you before. And for any dielectric material it is greater than 1. Okay. For any dielectric material or kind of insulator, it's greater than 1. Right? One second. For dielectric material or an insulator. Yeah. Dielectric material or insulator, it's greater than 1. Okay. So equal to 1 when it's air, when it's air or vacuum. It is greater than 1 when it's a dielectric material or an insulator, and if it is a conductor, it is infinite. And now force, we just studied it, kq1 q2 divided by r square, but there is another formula QE, where E is what? It's electric field. So we'll study it later, but just remember it for now, okay? And A equals to QE by M, where E is again, where QE by M, where E is again electric field, but sorry, E is electric field, but you have to remember it, okay? A, where A is acceleration, A equals to F by M, so A equals to QE by M, okay? Well, that's it for today. We completed all the topics, and these were some important points that you got to remember. So, well, that's it for today, and very thank you for watching this lecture, and I'm very much sure that it must have benefited you, and let's keep learning with the rocket of Raftar. And thank you. This was your own very mentor, Nidhi. Thank you very much, and keep learning with the rocket of Raftar. Thank you.